Okay. So, okay. Can you see my screen?
Yeah.
Okay. So our first chapter is for the additional mathematics code is additional mathematics, and our paper has P12 and P22 and code is 060. So we are starting from the chapter 1, basically functions. So functions, what are you saying about the functions? You know, function is the one correspondings, or they have here we have the here we have the input and output. Here we have the input and output. And this is called the domain, and this is called the range. I'm explaining you this one. After this, I'm giving you the theoretical definition of the functions. Okay.
Yeah.
Okay. So any point, if you are feeling hard, you can stop me and you can ask me the questions. Okay.
Okay.
So here we have denote it with the f of x is equal to some function. Suppose that I'm writing the basic function 𝗂𝗃 plus 4, 𝗂𝗃 plus 𝗂𝗃 plus 4. So you know this side is equal. This is called the y side, and this is equal to x, and this is also called the dependent, and this is the independent. This side is depend on this side. This is called the outcomes, and this is the input. Okay. So
Yeah.
any confusion?
No.
Okay.
No, sir.
Okay. Okay. There is no need. We are writing this function in this format: y is equal to 𝗂𝗃 plus 4, and there is not a mandatory the function is between the x and y. We can use the u and t, or we can use the v and w. These are the constants or variable. They can be changed. Suppose that I'm making the function. This is u is equal to 4v² plus 5v plus 10. This is also the functions between the u and v. Okay.
Yeah.
Okay. So after this, I'm moving to the basic definitions. A function is a root that assign the exactly one output to the each input, to the each input. This is called the functions assigning the. So here I'm just making the that one functions. If y is equal to 𝗂𝗃, so what is the definition? I'm telling you the function is a rule that assign the exactly one output to the each of the input. So I'm using the definition of the when we are assigning the input, we have the output, and we are using that definitions. So suppose that here already we are discussed, this is our real, and this is 0, and this side is positive, and this side is our negative. And you know, when we have put x is equal to 0, so y is equal to 0 plus 4, this is equal to 4. So our order pair is what? This is 0 and this is 4. And you are already know that in order pair we have the first one is x, and we have the second one is relating to the y. Okay.
Yeah.
So when we have put let this is equal to let. Okay. Then again, if we have put x is equal to 1, so our y is equal to 1 square plus 4 is equal to 5. So our order pair is 1 and 5. Again, we have put x is equal to 2. So look at here. our function is what y is equal to 2 square plus
6.
4. This is the no 2 square. This is the
38.
8. So our order pair is what? Order pair is 2 and 8. And look at here, I'm putting the x is equal to 3 from the positive side. From the positive side, here I'm working the positive side, and after this I'm working on the negative side from the real line. I'm putting the positive number. So this is the 3 square, this is the 4, this is the 9 plus 4 is equal to what? 13. So this is 3 and 13. After this, we are moving to the negative side. Now we are working on the real line of this side. First we are working before this side. Now we are working on this side. So x is equal to -1. When we have x is equal to -1, so this is the -1 square plus 4, this is equal to 5. When we have put x is equal to -2, so this is equal to -2 of square plus 4, this is equal to 8. So our order pair is what? -2 and 8. Here we are writing this is the -1 and 5. Got it?
Yeah.
After this, I'm moving the x is equal to -3, and y is equal to, so -3 of square plus 4, this is of the 13. So our order pair is -1 and 13. Clear that one?
Yeah.
Okay, here we use the function definitions. Function definition is what we give the input and we got the output. So basically, in roughly language, we are saying that function is a machine. Function is working like as machine. Suppose that the microwave oven is the best example. You have much more examples, but I'm giving you some specific example. The microwave oven. When you put your meal in the microwave oven, and you can set the timer, the meal will be the cooked or heat up according your input. If you are setting the oven function is just for heating, and just for heating for the 3 minutes, you are put the timer 3 minutes. After the 3 minutes, the timer is ringing, and you can bring your meat from the oven, and you can check the your food is hot. And here in whole example, input is what? You can put the timer, and you put the food in the oven, and you put the timer, and after the 3 minutes, your result is what? Your food is hot, and your microwave oven is stopped. So here is you are using the function. Basically, function is the most important technique, term, rule, tool for the mathematics as well as computer science as well as data science. Here I'm giving you some application of the function. So basically, I'm linking the function with the physical applications. Anything issue?
No, sir. No issue. I understand.
Okay. Here I'm just giving you some physical application, because most of students can face these questions from the audience or from the colleagues, why we read these read the mathematics, or why we read the functions, and why we need it, or where it applies in the physical life, and why we study it, and this is a whole rubbish, or this is the not for the good. And they are thinking math is nothing, and they are working like as burdenized subject, and just they are doing the pass. After this, they can skip the mathematics and they can run away. But here I'm just giving the physical application to link it with the physical life, so that you understand where we are put these functions. Okay.
Yeah.
Okay, after this, I'm using the function definitions. Here we have we define the function. Now I'm using these values, these on the behalf of these values on the input and output. We are seeing that what is the domain of that function. I'm writing it domain of that function f of x, or I'm writing it domain of y. So domain of y or domain of the f of x, when we have put the all values from the real line, and that function is defined everywhere. Okay, here we have the two type of cases. One is function is defined, one is undefined. But here we are studying first case, function is defined. After that, I'm giving you the second example for the undefined situation. Okay.
Yeah.
So here this function is defined everywhere. So I'm writing the minus infinity to plus infinity. As we already discussed in previous section, this is our open interval. Minus infinity and plus infinity are not included, but their numbers are also excluded. Sorry, their
Yeah.
numbers are included, but infinity and infinity is not included. They are excluded. But the second number of the infinity is included. So this is the domain. On the behalf of the domain, what is the range or what is the outcome of that functions? What is the range of that functions? Can you tell me?
Yes, range, it depends on what the least value can be and the most value can be, and then the answers will always lie in between that range.
Yeah. So on the behalf of this one, I'm underline that points. So this is our range point. This is also our range point. This is also our range point. This is also our range point. This is because the values of the y. This is the range. This is the output. So from this one side, our range is on the behalf of this side minus infinity to plus infinity. There is a one more key point. Keep it in your mind. If our function is breaked or undefined at some point or points of the domain, so our range will be the also break accordingly these points. Okay, but here we have the domain is all real number. In chart format, we can write it real number. Also, we can write it the real number. So this function is a real number. Okay.
Yeah.
You have looked that example again. Please, is there any confusion?
No confusion, sir.
Okay. So basically, main objective of this example is to doing using the definition of function. We can calculate the our domain, also our range, and also we are checking that function is continuous everywhere. The function is not breaked. So function is defined everywhere. But I'm giving you the second one example. So basically this one example is also from your book. Example are problems. Example or problems is what this is y is equal to 1 over x plus 2. 1 is equal y is equal to 1x plus 2. So look at here. First one is our to find the point where the function is undefined. Before of this one going through, I'm telling you the function is when will be the defined or when will be the undefined. Suppose that our function f of x have the two points. This is first is defined and second one is undefined. We already discussed, but here something over 0, something is over 0. This is the undefined situation. We can exclude that point of the domain, also the range. Okay, something and
Okay.
second one position is what? Negative under root. This is the harder level. This is the advanced level. But in your book, we are just follow that point. This is for the advanced level. I'm just telling you because I think you are studying the complex number, iota numbers, because this is iota is an imaginary number, and we are know that iota square is equal to -1, and we don't know the specific value of the iota. This is the iota is the imaginary part, and this is the supposition quantities. That's why negative under root is also where when we put the domain numbers, we have the range this type of format, or we have the output in this format, so we can exclude that point. So in your book we are studying that point, and on the behalf of this one side, our function is x plus 2. Suppose that this is x is equal to minus 2, and when we put 1 over minus 2 plus 2, this is 1 over 0. Look at here, we have this one type of situation, something over 0. This is also equal to undefined, so this is equal to infinity format. So at that point our function is at the point of x is equal to minus 2. So from the if I'm making the real line, this is your 0, this is 1, this is 2, and this is minus 1, this is minus 2. So from that point, from this point, our function is breaked or undefined. Okay.
Yes, sir.
Okay. So what is the domain of that functions? How I am writing it?
Two.
Before of this one, we are checking where the function is unbreakable. Just for your understanding, when we have put x is equal to 0, so this is 1 over 2, so our 1 over 2. When we put x is equal to 1, let x is equal to 1, this is 1 over
3.
3. And when we put x is equal to 2, you just put randomly, you just put the randomly 2 or 3 points from the positive side, from the negative side, also on checking the at point 0. When we put x is equal to 2, you have y is equal to what? 2 plus 2, 1 over 4. So this is 2 into 1 over 4. And same for the negative side. If I'm put the x is equal to minus 1, so this is equal to 1 over 1, this is 1, so this is minus 1 and 1. So already we have checked x is equal to minus 2, this is the 0. And when we put x is equal to minus 3, so this is y is equal to minus 3 plus 2, this is minus 1 over 1, this is equal to minus 1, so minus 3 and minus 1. Okay, so on the behalf of that one functions, what is the domain of that functions? So domain of that function is
0.
no, we are writing r minus 2, or we are writing like this type of functions, minus infinity to minus 2 union minus 2 to minus 2 to just this is the type of mistake. So minus 2 to plus infinity, or you are
What do
writing.
you,
Mhm.
what do you mean by union?
You are not knowing to union about union.
Is it in the one which you do in sets, like the same thing?
Yeah.
Okay.
Union, you are also, I'm just explaining you with the example. Suppose that our A is equal to 1, 2, 3, and B is equal to 2, 3, 4, and 5. So you know A union B is equal to A union B is equal to 1, 2, 3, 4, and 5. 5. Okay. So
Yeah.
here this is the union, but I'm writing it in the open interval. Minus 2 is exclude. Okay.
Yeah.
Okay. So or you are writing like this type of format. This is okay, minus infinity to plus infinity. This is minus 2. This is already we discussed, is like the complement of the sets already we know.
Yes, sir.
So I'm writing the same thing, but in writing the three type of the format. Can you understand each format, please?
Yeah, I understand.
Is there any
I'll
confusion?
no, sir, not that. I'll write it down also.
You don't need to write it because I'm already giving you the link of that whiteboard. View the Microsoft team, and also I'm pin it. You just click
Okay,
on this and you can access
okay, sir.
every time, not in the class, before and after the class. Okay.
Yes, sir.
Okay, on the behalf of that, what is the range of that functions? Range of that functions. You know, I'm already telling you our range is outcome, and outcome is depending upon the input, and the range is depending upon the domain. So this is your domain. Also, you are right, minus infinity to plus infinity, but my included minus this. Okay.
Yeah.
Okay. Here. No, we are moving the second one step. If I'm telling you, can you create the function? Can you create the graph of that functions? If we
I
want
can
to.
create.
Okay. Okay. You can send it me via WhatsApp. Take the picture of this one problem and send it to me the WhatsApp. Okay.
Can you tell me the function? I'll do the graph.
Yes. That functions we are using, how we can draw the graph of that function. Y is equal to 1 over x plus 2.
Y equals 1 over x plus 2. Okay, I'll do it.
Okay.
Y equals 1 over x plus 2. Y f of x, y equals 1 over x plus 2. Is it x plus 2 as denominator? Can you write it once? Okay, that. Understood. I'll do it.
Okay.
Graph, yeah. Huh?
Can you done it?
Almost, sir.
Okay.
So how is the graph supposed to look?
We are making and draw it here, and we can check it. Okay, you can send me your work. I'm checking it, and then I will explain you how it works. Okay.
Okay, so I'm gonna with the phone. Just a second. Yes,
Okay.
sir. I just I don't
Okay.
think it's right because I never saw a graph that looks like this.
Okay. No issue. No issue. I'm explaining you how it works, and don't be need to make the graph on the graph paper. You just make it on the simple pages. And
Yeah.
first of all, we know how to draw the graph of that functions. We have already know when we have put 0 and 1. Here we are writing the order pair. This is 0 and 1, and this is 1. And when we have put 1 and 1 is equal to, so this is when we put 1, this is equal to 1 by 3.
Yeah.
Okay. After this, we have put 2 is equal to 1 over 4, and 3 is equal to, when we put 3 is equal to 1 over, so our function is what? 1 over x plus 2. This is equal to 1 over 5. And same for the negative side. When we have put -1, I'm just collecting the order pair. So this is the -1, this is equal to -1 and 1.
Yeah.
And we know we have t is 2 is breakpoint, and 0 minus 3. This is equal to minus 3. This is equal to what? This is minus 3 and this is equal to minus 1. On the behalf of this one, you can draw the graph. And as you know already, here is the x is positive, here is the x is positive and y is also positive. This is your y side, this is your y negative side, and this is your positive side, and this is your x positive, and this is your x is negative side. You are already know. When we draw this one graph, so 0 and 1, our x is 0 and y is equal to 1. We are moving to the at this point. When you know 1 over 3, when we are dividing, this is equal to the 0.03. So x is equal to 1 and we have the y is equal to 0.3. So our suppose that our point is here. When we have the 2 is equal to 1 over 4, and you know this is 0.25. So this is the 1 and 2, and this is your suppose that this is your next one is 1 over 4. When we put x is equal to 3, this is your 3, and this is your here is the your point. So for the minus 1 and 1, when we have put minus 1, so our x is equal to minus 1, we have the minus 2. So our point is here. And you know,
Yeah.
x is equal to minus 3. When we have the break, at this point, we have the break. I'm denoting it with the minus point. This
Also,
is
my graph is correct.
yes. So I'm disconnecting. For the disconnection, I'm writing it with cross sign. This is
Yeah.
cross. Okay. For your understanding, you know, at the undefined point, our function is almost break. Okay.
Yeah.
At the at minus 3, you know, when we have put minus 3 and we have the minus 1. So our function is like this one. And when we put our functions at this point from this one and this one and this one and this one is working like this type of along the x-axis to the near to the x-axis, not onto the x-axis, and almost working on the x-axis. But here, look at here. So look at here at this point. Our function is at this point, our graph is breaking and our graph is working to the I'm denoting in the dotted line, also from the dotted line, and here is the break point. I'm writing it here.
Yeah.
Okay, so from that example, we also calculated how the function is making or how we are working on the graph using the function. And secondly, what will be the happen when the function is discontinuous or break at some point or points. There will be also a break point in their graphical representation. And this function is also a discontinuous function at the point 2. Are you understand it?
Yeah.
So any confusion regarding this one problem?
No problem at all. I understand.
Okay, from this one, from your book, I'm just explaining you the odd numbers from 1 to 9. Another part of this one.
Yeah.
Odd numbers from 1 to 9 inclusive. So from 1 to 9 odd numbers, basically he want to check or he want to asking you about the domain and range at starting from the here. No, our question is bounding. Here the examiner bound us from 1 to 9 points using the odd numbers. So on the behalf of this one, I'm just writing 1, 3, 5, and 7 and 9. We already know at 1 and 1, we already check it. We already check at this one point. So our function is y is equal to 1 over x plus 2. So you just put the x is equal to 5 in this manner. So our x is equal to 5. Y is equal to 1 over 7. So our graph is 5 and 1/7. When we have x is equal to 7, so x is equal to 7, what is y is equal to 1/9. So this is 7 and 9. When we put x is equal to 9, so our y is equal to what? Our y is equal to 9 plus 2 is equal to 1/11. So this is 1/9 and 1/11. Got it?
Yeah.
So now I'm moving to the second one part of this one example, this one problems, the part 2. This is the problem from your book, book. So inputs, even numbers. Even numbers from 2 to 10 inclusives. So your input is what? 2, 4, 6, 8, and 10. Look at here. Our function is what? Y is equal to x plus 2. When we put x is equal to 2, we already know this is 1/4. And order pair is 2 and 1/4. And x is equal to our 4. This is y is equal to 1/6. So 4 and 1/6. And so on for the 6. So our x is equal to 6. This is y is equal to 1/6 plus 2. This is equal to 1/8. So this is equal to 6 and 1/8. And now for the next one part, our x is equal to 8. So y is equal to y, or you are writing same for the f of x. So this is 1/8 plus 2, this is 1/10. And this is 8 and 1/10. Got it?
Yeah.
Okay. After this, we are put x is equal to 10. So our 1 is equal to 1/12. So this is 10 and 1/12. Got it?
Yeah.
So here is the total example is completed. Problem is completed. First one is asking the where the function is breaked and what is the graphical representation or graphical behavior of that function. We are also solve it. And after this, he has bound us to the input at 1 to 9 from the odd numbers. After this, he is giving the input from the 2 to 10 is even numbers. Okay, and now we can find it. And also we are finding the domain and range of that function. And also we can draw the function of that functions of draw the graph of that functions. Okay, any confusion regarding this one problem?
No, sir, no confusion.
Okay. After this, we are just moving the this one side and just